In this video, we are going to discuss about stable equilibrium and unstable equilibrium. Okay. So before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. Right. And if you want to follow me on Insta, this is my Insta ID. This is my Insta ID. That is Oja, OJHA, Lakhyajit, LAKHYAJIT 123. This is the Insta ID. If you want to follow me on Insta, you can follow me. Okay. So now let's start. Now you say, what does stable equilibrium mean? Now you see, if a slight displacement of a system from its position of equilibrium results only in small bounded motion about the point of equilibrium, then the system is said to be in stable equilibrium. That means, suppose let us consider a pendulum, suppose simple pendulum. This is a simple pendulum, suppose. Now you see, if you displace it, if you displace this ball, right, and if you release from this point, then it gonna oscillate about this position of equilibrium. This is called position of equilibrium, when it was at rest, where it was at rest, right? So it oscillates about its point of equilibrium, right? So then this system is said to be in stable equilibrium, right? And what is unstable equilibrium? Now you see, if a slightly displacement of the system of its equilibrium results in unbounded motion, then the system is said to be in an unstable equilibrium, right? Now you see, suppose we have a rod, or this is in cylindrical form, right? Somehow if you manage to balance it, to keep it vertically on a horizontal plane, right, on its small base, on its one end, right? Now you see, if you slightly displace it, right, then it's gonna fall down like this, okay, and it cannot come back to this position again. So then it is said to be in unstable equilibrium. Or you can consider this condition. Suppose you have a surface like this, and if you manage to keep a ball here somehow, which is now balanced, right, so it is not falling down now, suppose, and if you move it slightly from its position, then it's gonna roll down, right, but it never come back to this position. Okay, so this is also an example of unstable equilibrium, right? Now you see, there is one more kind equilibrium, that is neutral equilibrium. That is, here you see, suppose you have a horizontal plane, suppose here you have a ball. If you bring this ball to this position, then it stays at this position, okay. If you bring it at this position, it stays at this position, okay. It never going back to this original position, and it stays where you keep it, right, on the horizontal plane, right? So that is, you see, natural neutral equilibrium. That is neutral equilibrium. Now you see, let me show you two graphs here. So here V represents potential. If you draw the graph, here you see potential is the function of x, where x represents position. Then so this point, this position, this is point of stable equilibrium, and this graph for a system of unstable equilibrium. So this is the position of unstable equilibrium. Okay, so now you see in the figure A, in this figure, at the point if the particle is displaced, okay, the force f of x, which is equal to minus dv by dx, okay, so we know force is negative gradient of potential, is directed towards the center of the force and the particle will tend to return. So that means, suppose, so as I have given you the example of simple pendulum, right? So if you displace it, then a force that will try to bring it back to this position of equilibrium is minus dv by dx, right? And it will tend to return to this position, right? And on the other side, in case of unstable equilibrium, if the particle is displaced slight from the point of equilibrium x naught, so here I have to mention if the particle is displaced, okay, just okay, it will be acted upon by a force f of x minus of minus dx, the dv dx, so which is becomes a positive dv by dx, which tend to push the particle away from the equilibrium point. So that means, now if you consider this case, so as you keep the ball here, and if you somehow manage, you manage to balance it at this point, you manage to keep it this point, okay, so then if you push it just a little bit, then it's gonna roll down, right, and it's gonna never come back to this position, right? So then in that case, the force that gonna act on it, that will be given by F is equal to dv by dx, okay, dv by dx, and this force will push it away from this position, away from this equilibrium position. The equilibrium position means the position at which it was when it was at rest, right? So on the other hand, in case of this simple pendulum, what was happening here, when you push it slightly, okay, then the force, it tries to pull back towards the equilibrium position in this direction, that was negative dv by dx, right? So hope you have understood this, what is stable equilibrium and unstable equilibrium, right?